Okay, so just to give you a little bit of overview about today's discussion, I'm going to talk probably less about biochar, but also I'm going to bring up the point that it's very important for the underpinning of this talk I'm going to be giving about essentially looking at potentially redistributing biomass across the landscape. So just going to go ahead and dive into it. And so just so you're aware, the Forest Service and the forest itself has a significant problem in a lot of places where we have too much organic matter on the surface, and that potentially can lead us to elevated wildfire fuel risks. So once again, the more fuel that you have on the landscape, the potential for a long duration, high intensity fire starts to develop. And while some people don't really distinguish between types of fires, the longer a fire burns on the landscape and the more intense it burns, the more damaging it can be to the environment. So a short duration, low intensity wildfire would actually produce more charcoal. So it would be a better benefit to have that kind of, if you're going to have a fire, and we're going to have a fire, the question is not if, the question is when, to manage to that and try and reduce the intensity of the actual fire itself. The other thing I'd like to point out is timber sales, which is our typical land management practice, tends to focus on fuels that are greater than 1,000 hour fuels. So these are 3 inches or larger pieces of wood. But unfortunately, the wildfire risk comes from those pieces of wood that are less than that diameter. So there's a bit of a disconnect, and we're trying to see if we can remedy that with this discussion and some things that we've got going on. So when I talk about too much organic matter, I'm not going to have pictures of these large wildfires, because everybody's seen it and maybe seen it a little bit too much of it after this season. But this is an example of what happens when we have no offtake, especially of the smaller diameter material. So this was done to reduce the wildland urban interface wildfire risk associated or in and around the Flagstaff area. That pile that you see is actually about 4 acres, covering a mountaintop in the Flagstaff area. And as I was told, I didn't take the picture, but I was told that slash actually was at about a 20-foot depth. So that was a significant amount of material. Unfortunately, there was no nearby mill to take either the logs or that slash for a cogen use. Unfortunately, that pile did ultimately burn in a wildfire event, which can lead to a whole nother scenario of wildfire or landscape risk. But that's for another talk. So now we want to start talking about, so the common denominator here for Forest Service land management is we have an excess, but then there's also a place where there are deficits. So some farms are looking to build soil organic matter. A lot of them have too little based on their environmental conditions, their farming practices, or other things that are dictating how much organic matter they can store and hold on to. So as we get into that discussion a little bit deeper, there are actually USDA agencies focused on increasing soil organic matter on the farm. They are focusing specifically on 3 types of organic matter: fresh, the newly available plant matter that's out there, the decomposing or actively decomposing organic matter, and then there's the stable organic matter or humus, potentially biochar. So that's where we see the opportunity to maybe tap into this kind of work. So I'm going to go back again and start talking about a little bit more about the forest problem and just show you this picture. So this is an overview of Oregon or Washington to the north and Oregon to the south. And what these circles are is an opportunity to move material to centralize plants, such as what John Ovinsky was talking about and others previously. We have the ability to move this material unchipped so that we don't end up losing the merchantable value of the larger pieces. And then once we get it to a sort yard opportunity at the center of those circles, we could high grade everything that's in the pile for any merchantable purpose, and then the rest of the material can then be utilized for bioenergy and biochar. And I'm wanting to make sure that I have your attention on these gaps. So wherever there's a gap between the 50-mile radius, and the yellow is a 75-mile radius, but wherever there's this gap, we have a break in the continuity of landscape management. And that's what the Forest Service is concerned about overall. We're not really focused on making these products as much as we are in managing the landscape. So that's kind of where my discussion is going. So you'll see these breaks in the landscape, if I don't lose my cursor, there it is, such as here there's a break, here there's a break, between Medford and I believe that's Eugene. There's potentially some breaks, and between Bellingham and the Portland area there and Hood River, there's some breaks. So that leaves us with some work to fill in those gaps. Now, when we have this biomass taken to a central facility, we have the ability, like I mentioned, to capture the value of the wood before it's lost to a chip. We could potentially sort out saw logs, post and pole, fiber logs, which could be used as solid fuel to torrefaction or pellets, or liquid fuels, such as what's going on at Red Rock in Lakeview, Oregon. Then there's potential to take this material to firewood, beauty barks, composts, and mulches, and simultaneously, then when the fuels are brought down to the point where there is no merchantable purpose, then we can use it with some measure of this other material up here to gain the right BTU values. We could make bioenergy to feed the production of all this other stuff above and simultaneously make biochar from it, giving us the ability to both capture and move the biochar, because that's the problem. It's not that we don't have a purpose for it, it's just so costly to move it. And that's to move the raw materials to make the biochar. Now I want to discuss the opportunity in those gaps that we had seen in the previous slide. So where we have a gap, there is no feasible way to move that material for a merchantable purpose. So that gives us an opportunity to take some kind of mobile equipment, whether it be this system that's potentially going to be available through Air Burners Incorporated, or the Tiger Cat unit, which is a bigger unit, but has the same kind of purpose. So either one of these pieces of equipment can fill the void, giving the Forest Service the opportunity to manage across the entire landscape instead of just at the timber sale scale or the bioenergy scale. we need to be able to manage at a landscape scale. And that's where our interest lies. So just to give you a little bit of background about this, we actually were using this piece of equipment last week, did some work in Bandon, Oregon, where we were converting gorse, which for those of you who are not aware is a very thorny nightmare. And it's not fun to have to walk through or do anything in, but we turned that material into biochar and did it with very low to minimal smoke. So we were hoping to achieve that, and we feel pretty confident that we did. And then we took this unit we started on Monday in Bandon and ended up in a place called Tollgate, Oregon, which is on the east side of Oregon, and did the same thing with timber sale debris that had been piled up and left in place. So these are the scenarios where we could cover the fuels reduction either from a timber sale or from some kind of biomass removal or restoration work that's occurring, and it could give us the opportunity to make the material that could benefit that work. And this is how we could potentially do it. So this is where we applied some biochar on the national forest on a very coarse soil. One of the previous presenters had talked about applying biochar in very poor soils, and this is the place they were talking about. So this is Fish Creek Desert on the Diamond Lake Ranger District of the Umpqua National Forest. And it's a very coarse, freely drained soil. The thing that I was really interested in when we started looking at this stuff is not only can it move into the system, but how we can move it into the system. So if you'll notice this photo over here that talks about the hydrophobic conditions, one of the things that we recognized is that when we applied this material, we had to actually till it in, or you can see the drift. We were losing it from the plots. So at the right particle size, you can just put it onto the surface. Unfortunately, this was a very fine material, so we had to actually till it in or risk losing it during that event when we were making the application. But I want to point this out too. So dependent upon where you put this material in the landscape, you can just put it on the surface, and as long as it's available to freeze thaw and other physical weathering mechanisms, it could potentially become hydrated, stay in the water column, and then just follow the water into the soil, which is probably the lowest cost application that you could find. And potentially you could do this in with CRP fields through the NRCS, or no-till farming. You could use it to just get the water to move the material in rather than tilling it, dependent upon the particle size of the material. And this is the result. So what we see on the left-hand side is the biochar application, and this red line is the demarcation between the plot, the biochar plot, and outside of the plot. And what we see here are two grasses in the red circle, same species. I think this was an Idaho fescue. I'm not a botanist, so I don't remember them or want to make it sound like I am, but anyway, these are the similar species. The plant to the left inside the plot was considerably coarser. The seed head was considerably coarser. The stalk was considerably coarser. There was more available biomass above ground, just in the plant itself. Now, the other thing that we want to notice is outside of the plot to the right, the stalk is considerably spindlier, the seed head is considerably smaller, and then also note the color difference between the two grass species. And the reason I bring this up is because this gives us an opportunity to increase the live fuel moisture of plants, especially grasses, which can be the fine fuels that are the initiator of wildfire. So the reason I bring this up is the previous photo was when we had applied the biochar in the beginning of April. This was a photo taken the same year, 2010, in August. The location is Fish Creek Desert, just to give you an idea of how beneficial this can be. So the benefits that we ultimately saw out of this were, we saw that overall there was an increase in soil organic matter, which can give us a benefit potentially to the NRCS and their clients. Through the NRCS, we come to understand that by increasing by a 1% increase in soil organic matter, which could be extrapolated to a 12 tons to the acre application, you could potentially see 25,000 gallons of water holding capacity available through that application. Now, I'm saying capacity. There's no guarantee that this stuff can make it rain. So that's the other thing. So you just got to be aware that you're creating storage capacity in the soil as if you are adding more memory to your computer. You're just creating the opportunity for storage. Then as we relate this to timber, so increase in soil moisture potentially is an increase to trees as far as its board feet. And there are some people that may be concerned that, we're trying to, cut more trees or do large scale farming of the forest. But this benefit could be achieved whether it's in the matrix lands where we actually do harvest trees. It could be done in any of the areas where we may have harvest restrictions. So it doesn't matter where we're putting this stuff. The benefit would be in the size and the diameters of the trees ultimately. So there is also potentially a range benefit. As I had pointed out, especially with that picture there, the forage is, by having late season green forage like that, our wildlife managers are very interested in that kind of opportunity, because then we're able to take some of the big game into the winter with more nutrients available in their system, so they're more likely to have higher survivability rates in cow-calf pairs, whether it be for big game or for range. The other thing about having that increases in soil organic matter, especially in range, dependent upon how much organic matter is in the soil, will potentially could dictate how much compaction animals can create. So also, as I pointed out, the increase in soil moisture could potentially benefit live fuel moisture, which gives fire managers a potential benefit. And especially when you're taking the material down and breaking the continuity of the fuels ladder. So the fire starts at the ground, but then transfers up to the canopy, because there's a consistent fuel ladder. By breaking the ladder and forcing the plants to have a higher live fuel moisture, we're doing more to have a more resilience on the landscape from wildfire starts. And then as we look at the potential benefit of having more soil moisture, potentially we could look at reduced risk in crop failure. So Other government agencies that could be benefiting from that may be the Risk Management Agency, the RMA, who does crop insurance. They're the NRCS, who is spending a lot of money toward, as I pointed out earlier, reducing or increasing soil organic matter across the landscape for a variety of reasons. And these are just kind of like an overview of what potentially could be available through doing this work. And so, kind of an overview. If we were to do this in an equation kind of scenario, so land management biomass equation within the USDA itself could be that NRCS clients who are deficient in soil organic matter in some environments, and we take the problem that the Forest we take that first problem and combine it with the Forest Service problem of having surplus organic matter in some environments. The thing I want to point out is very often than not, these two environments are adjacent to each other. So the excess fuel loading and the organic deficits almost in every case tends to happen in the dry West. So this could have a very beneficial effect by combining these two problems into one USDA solution, which could be a systematic redistribution of organic matter across the landscape. And having these long-term ideas about it, or these abilities, could give us the benefit of being able to achieve this. And I want to point out this is the our Secretary Perdue often talks about being able to do right and feed everybody. And I think by us being able to manage the Forest Service biomass, we're able to do right. And then it gives us the opportunity to feed everybody.
Got about a minute left. Oh, perfect.
And that's it.